Good evening, students. To know the basics of the computer-aided engineering drawing and about the usage of SolidEdge, that's a version 19 software, we'll go with a sheet setup, how to do the common things which are involved in each and every pages. Then we'll move on with a problem related to the lines. See, whenever you open a software, the first page will be visible like this. So in this one, we are going with the drawing. So these many options are available which are not related for a time being. So if you click on a drawing, it will open up to a one sheet where exactly we are going to call that one as the active sheet, or in other words we can call that one as a working sheet also. If you go back to here in the main toolbar, okay, so here we have a file, edit, view. If you click on a view, here in the view you can see there are two options. There's a background and a working sheet. And in the left side you can see one is clicked and one is unclicked. That means the one which is available right now, that is sheet 1, is nothing but a working sheet. Okay. Now if I click the background sheet, so along with the sheet 1, you can see four options here. That those are like the sizes of the sheets normally we use. Okay, so you can see here we have a A4, A3, A2 and a A1 sheets. But normally in general, the one which we are going to take a printout, okay, using a printer and all, it's a normally A4 sheet, okay, general thing. So we need to just communicate with the software that see, the working area which you are displaying should be confined only to the A4 sheet. So now how to know in the sheet 1, okay, which sheet is displayed? So that is what the process is called as sheet setup. So to do that sheet setup, there are three options. Either you can go to the sheet 1, double click on that one, you will get this window, okay, one. And either right click on the sheet 1. Here we have a sheet setup, you can click on that one, the same window will come. Or else you can go to the file, and here we have a sheet setup, and again that same window will come. Okay, so whichever the process you feel, so you can just follow that one. Now for a timing, so easiest one is I will double click on the sheet 1. I will get this whatever the sheet setup window. So when I get this sheet setup window, in this one we are going to have three options. One is a size. Again here you can see that the standard and the displayed one is a A2. Okay, and one was the name. You can change the name here, that is also fine. Okay, and one important is the background sheet. Okay, as I said, right, in the view, when you are going to click on a background, okay, so you need to say so which sheet you are working. Okay, so here I need to check with the A4. Okay, then if I click just OK, okay, if I just click OK, so you can see here the size of the sheet gets reduces to the sheet 1. Okay, suppose I want to have a one more problem. If I click and insert here, okay, right click on the sheet 1, and if I insert one more sheet, so now see again the sheet 2 is of A2 sheet. That is, by double click on this one, okay, you can see here again it is a sheet 1, but I changed the whatever the background sheet to the A4, but I just clicked on OK. It has got applied only to the sheet 1. Okay, so if I want to continue that one for the remaining, if I insert so many sheets, okay, in the current sheet, okay, so it has to apply for each and every sheet. In order to do that one, what we can do, when we are going to double click on a sheet 1, when we are going to do the sheet setup for the sheet 1, I need to click on a save default. Okay, if I click on a save default and OK, okay, now if I go back to the sheet 1 and if I right click and insert one more sheet, you can see the sheet 3 is of a A4. Okay, I hope you understood the difference. If I click only the OK, if I click on the save default and OK, if I click OK, the changes will apply only for the current sheet. Okay, but if I click save default and OK, the changes will apply for the so many sheets which you are going to use it in the same file. Okay, you can use n number of sheets in the same file. The changes which you are going to do with the save default, those things will appear in each and every sheet. Okay, so that is what is important. So for a time being, I will delete inserted sheets here. Okay, so now this will appear very small. Okay, the A2 sheet is reduced to the A4. Now in order to get this one to the full screen, here we have a command called fit. Okay, so this is a very simple software where if you just click on, okay, or even if you just move your cursor on each command, okay, it will show what exactly it is, and it will show like what you can do with that whatever the command. Okay, so now I need to fit this one to the screen. Here we have a fit. So normally we observe the same type of what you call the icon, maybe while playing a video in a YouTube, or you want to change the portrait mode to the landscape mode in your mobile and all, you will see the same symbol. Okay, so if I click on this one, so it gets fitted to the screen. Okay, so whatever the things which are displayed standard, okay, on the sheet 1, you cannot change. Okay, in the sheet 1, so in order to do any changes, you need to go back to the background sheet. Okay, so in the background sheet you need to go for the A4 only. Okay, why? Because we have done the sheet setup for the A4 sheet. So now in order to just delete this one, okay, I can select and delete whatever the line which I don't want that one. Okay, for a timing, what we'll do, we'll have a control A and delete everything, even with the border. Okay, you can retain the border. For a timing, we'll delete everything. Okay, so now everything is done. Now my name, my whatever the section or USN number, okay, my chapter name, and whatever the faculty signature, everything will remain same for each and every sheet. So those things you can write in the background sheet. Okay, so say for example I want to write my name, I will go back to the text. Okay, here, okay, in this drawing view toolbar, the last one is of text. You just click on that one. Okay, once whenever you are going to activate any of the command, okay, so you can see here I selected. Here there is no option. When I click on the text, you can see there are too many options which are going to appear here. That is what is property toolbar, we say. Okay, the text is a normal one. Okay, you can change the styles, but here it is fixed. In the font style, you can change anything you want. Say for example I will go for a Times New Roman. The font size you can change. Say I will go for a 5 mm. Okay, and if you click somewhere at the down, I need the name at the down of the uh, drawing sheet. So I will write my name like, so Narayan Swami R. Okay, and I will write, say for example, my USN number or any of the USN or roll numbers, and I'll say for example D34. Okay, or else for your college, say B23. Okay, capital CED 23 CS 123 you can write. Okay, and I will click here, and then I will write like it is projection of lines problem. And once again I will click one more time, and I will write this is faculty sign. Okay, so you can type it separately, and you can move accordingly. Say for example click on this one, move to the boundary, you will get plus mark, and you can just place drag wherever you want. Say I will move this one in line with this one. Okay, and move this one a little bit up. Okay, keep it everything down, so these things will appear in each and every sheet. Or else put a box around that one, and continuously you can just drag at a time. Okay, you can just drop it like this, or else you can just go to the text, click somewhere here, need not go down, and I will write my name, my US number, then my title, then faculty signature, everything in a single box. And you can select the single box and keep it at the down also, that is also fine, like this. Okay, so there are n number of ways by which you can do that one. So initially whichever you feel easy, you can do that one. Maybe at the end, once you keep on practicing, you will be the master in that one. Okay, so these are the two ways by which you can do this one. Okay, so for a time being, so I will delete this one, and now you can go back to the sheet one. Okay, you can see here at the down. Okay, so whatever I have done at the in the background sheet, it is done, and we can see it here. Okay, so that's what exactly we can see here. So that's how exactly we can do. Okay, once these, say for example, if I want to do any changes here, if you select this one, see now we will not be able to select anything or change anything in this one. Want to change anything, again you need to go back to the A4 sheet, that's a background sheet. Okay, so now once these changes are done, better you go to the view and switch off the background. Now fit to the screen. Okay, so whenever you start a problem, make sure that like you will be having only the sheet one, nothing else. Okay, so for example, you are going to start a problem. Okay, so you can just go right click on the sheet one and you can just rename it. Okay, just rename. We said right while doing the sheet setup itself, there is a one option to rename. I will just show it once again. Okay, so here you just give a problem number. Say for example, so I am starting projection of lines. Okay, problem number 1. Okay, so you can just give it here and click OK. The sheet 1 will be renamed to the PL1. Say for example, I was talking about one option. Double click on the PL1. See here we have a name. Here also you can change. Okay, the simple one is just right click and just rename. Okay, the things will change for. I hope this is clear. Okay, so this is what is very very important whenever you are starting. Okay, with a new file and all. So first you need to say like, so you need to, okay, to the software. Okay, see this is the a size of a sheet which we are going to take a printout, and you need to display only that much. Okay, so you can see this border, that border is corresponding to the sheet 4. Okay, so that we can do it here. Okay, so now to start with the problem which we are going to have it here. So this is problem number 1 with respect to the projection of lines. Okay, so here we have, okay, to just have a little uh, broad introduction with respect to the lines and all. Okay, so whenever we have an option, okay, to just read the things and all. Okay, so here we have a problem number 1. So let me just copy the problem. Okay, so whenever we say, okay, with respect to lines, okay, normally we drop it under a one dimensional object. Okay, so where we are going to just give the problem or a line with respect to the length. Okay, so you can just keep it here, right? So whenever we want to understand things, especially in the drawing subject and all, very first thing is you need to just read the problem carefully, maybe once, twice, or maybe uh, number of times until you are going to understand the things which are there in that one. Okay, so now when you start reading the problem, okay, here in the projection of lines. Okay, so here we say there is a line AB which is of 80 millimeter. Okay, there is a line, okay, which is of 80 millimeter. So whenever we have a line, it will be having a two ends. Okay, you will specify. So there is a end A which is 10 millimeter, sorry, 20 millimeter above HP and 30 millimeter in front of VP. So that means like he has told the one end of a line, okay, it is situated 20 millimeter and 30 millimeter with respect to the both the planes. And he says like it is inclined at 30 degree to the HP and 45 degree to the VP. Means direct inclination is specifying. So draw the projection of the line, find the apparent length and apparent inclinations with respect to the line. Okay, so means whenever we are having a lines problem, so here there are two terminology we need to understand. One is we call it as a true length, and one more we call it as a apparent length. So normally the best example we take up in order to understand what is this true and apparent length is, say for example you have a bucket of water. Okay, and in that one either you put a coin or put a stick or a scale, whatever the thing. Okay, and when you look that one from either from the top, okay, so you will see as if, or maybe if I have a transparent bucket, okay, you can see look from the side also. So it as if looks like it is the coin is nearer to you. Okay, but when you're going to put a hand in order to get that coin, you will come to know like the actual length of that one. That means the actual length of a line or the object or the distance is a different one, and the one which appears is a different one. Okay, the one actual is called as a true length, and the one which it appears is called as a apparent length. Okay, normally if you take the same example with the scale or something like that, okay, the length of the scale gets shortened. Okay, you can see it as if like contracted. Okay, but the inclination, okay, so will be little more compared to the uh, initial inclination. Okay, that means for a line problem, normally whenever we are going to read, okay, so we need a few data here. Okay, so what are the data we are going to collect here is one is a true length with respect to the line. Okay, and one is a apparent length. Okay, so that means we are going to have a line with respect to the top view and with respect to the front view. Okay, then one more will be the true inclination. True inclinations. Okay, so one is with respect to the HP. So that is what is called as a theta, we say. Later we will have the um, symbols, and one more with respect to the VP. So that we are going to call as a pi. Okay, that again will show the symbol. Okay, there are true inclination. There are two more apparent inclinations. Apparent inclinations. So that is again with respect to the HP. We call that as alpha, and with respect to the VP, we call that one as a beta. Okay, so ultimately at the end, so we are going to have the ends, the datas with respect to the locations of the two ends. Two ends. Okay, so here it is AB. So we say that is A with respect to the HP with respect to the VP. Then end B with respect to the HP with respect to the VP. Okay, so these are the things which are important for us whenever we are going to read the problem. Okay, so solution anyhow, graphically we can just start solving. Okay, but whenever we are going to read the problem, you should keep all these things in your mind. Okay, then the things will be easy for us to understand the thing. Okay, so now when I have this what you call, you can say like a checklist, whatever the things. Okay, but you can just now keep on reading the problem. So there is a line which is of 80 millimeter. A line is of 80 millimeter. That means it's a true length. So now we can say the true length they have given it as a 80 millimeter. That's the first thing. Okay. Now there is no. If you keep on reading again here, okay, in the at the end, draw the projection of the line and find apparent length and apparent inclination. That means here, so apparent length is not there? Question mark. Okay, in the both the views. Let me just okay, so apparent length, both the apparent lengths are not there. You can just put a question mark there. Okay, and both the apparent inclinations are not there. Okay, so we need to find that one. So in the easiest way, you can just eliminate the things which are not there in the problem. Okay, that will avoid too many confusions. Okay, so both apparent inclinations are not there. That means he has mentioned the true inclinations here. Okay, so that is what we can understand. Okay, so the end A is 20 mm above and 30 mm in front. That is what we have located here, the two ends. Okay, so one end is specified with respect to the HP, it is 20 millimeter, and with respect to the VP, it is a 30 millimeter. Okay, so this already we know how much is above and in front means it comes in the first quadrant, and normally like the lines problem or the remaining problems, normally we go with respect to only the first quadrant. Okay, so this and end B has not specified anything, so this data is for a time being they are not given, we just ignore it. Okay, so in whichever the problem he specifies that one, so as we move on maybe in the next category and all, we'll see what and all the things will appear. Okay, so these many things are specified clearly. Okay, so what are the things? One is Let me just drag it a little bit. Okay, so one is a true length, that is what he says. There is a line AB which is of 80 millimeter. Okay, then apparent length we need to find, that is what he has asked at the end. And a true inclination, he has specified it is inclined directly to the HP and VP. And apparent inclination we need to find, there are two ends and he has specified one end here. So once we know this one, okay, so then we can start the problem by taking the data what and all they have given here. Okay, let me just keep it here. Okay, you need to so just in order to show a demo, like we are having the problem sheet here, so instead of that one, what we can do here is you can just drop it on your sheet, okay, where you are going to work out that one, and you can just move on. Okay, so to start with the problem, so here we have a line. Okay, once you click on a line, we need to have a xy line which is of 0.13. Okay, so that's a line which differentiates VP with respect to the HP. Okay, so we'll say this is X and this is a Y. Okay, so normally we prefer to have a VP here and the HP here, and normally in order to understand it in a clear way, okay, so we say with respect to the VP, okay, so always the best friend of VP is a front view, and with respect to the HP, the best friend of the HP is the top view. So the front view appears here and the top view appears here. Okay, so now very first thing is we need to locate the ends. Okay, so he has specified one end, so I will go back to the line, check whether it is a continuous line with a 0.13. Then I will click to the left side somewhere on the XY line. So when you come near to the XY line, the cursor, the line will change to the red color, and you can see the line is initiated here. Okay, so 20 above means it's visible in the front view. I will enter 20, then enter 90. Okay, so you will get a one end. Okay, my automatic dimension is on, and switch it off here. So you can see if you just move on the cursor, it will show auto dimension. Just unclick that one, and again I will go to a line command. Okay, again 0.13, move on this line again on the XY line. It is 30 in front, so 30, enter, so minus 90, enter. You'll get a one more end of the line. Okay, so now let me just go back to the text command, and I will say this is my a dash and this is our a. Okay, just I will go to the zoom area command. Just for timing, I will just zoom this one. Okay, just to have a proper clarity. Okay, now to check, okay, whatever the dimension we have applied is proper or not, we will go back to the smart dimension. Okay, and click on the dimension 1 and 2. Yes, it is proper now. Okay, so we have located one end. Okay, and we need to go further with the where exactly the other end is going to appear. Okay, so this one is done. Okay, now you can just draw. So this is your locus of A and locus of A. Okay, you can just drop it, and you can just say like these are your locus lines. Okay, so the same way you can just drop it here, and you can just copy. You can just press Control and Alt left click, and you can just drag it. Okay, it will just come as a copy paste. Okay, so that also we can do it here. Okay, so once we locate the one end of a line, the next thing is he has specified the true length with the true inclination. That is, true length is 80 and true inclination with respect to the HP is a 30 degree. Okay, so what normally we do, we'll take a line. Okay, we'll initiate from the A dash, that's a one end. We need to locate one more end. Now with the length we'll enter 80, the true length, and the angle as a 30 degree. True inclination with respect to the HP. Okay, so this one is in, just right click, and the same thing, something went wrong here. Okay, so we'll just have one horizontal line. Is this fine till here? Okay, we'll initiate a line from the A. Okay, so now in the length again, true length 80. The angle is 45, so it is coming down. So I will have enter minus 45. Okay, so this is where exactly we are going to get the end B. Okay, so let me just name it here. Okay, this normally we specify it as B1 dash and this one as a B1. Okay, so now for time being, I'll go back to the background sheet and I will delete these things just to have a clarity with respect to the problem. Okay, so this is what is B1. Okay, now once you get a one more end properly, so what you can do here, okay, you can just draw one more horizontal line. Okay, so horizontal from the B, you can just see like when you move from the B dash, okay, so there is a dotted line which will be appearing. Just click and just drag. Okay, the same thing B1, move to the left side, we need a reference, just drop a one horizontal line. You're going to get that dotted line if the alignment indicator in the tools is on. Okay, so we need those what you call locus line. So as I said, you can just copy the same locus line here. Okay, I said right, click on the locus line, move to the boundary, you'll get a plus mark, press hold control and left click, hold it and drag it. That's the easiest way to copy paste the things. Now let me just check like whether the length and angle whatever I have entered is proper. You can go to the smart dimension and click on this line, just drag 80 millimeter, fine, just drag 80 millimeter, fine. Now in order to do the angle between below the smart dimension itself, we have an option here, right click, okay, right down arrow, angle between. So click on both the lines where we need an angle, just drag one and here, just drag here, so one. So everything is fine. You can just zoom the connected points here properly. If it is connected, fine, everything is okay. Now we got a true length. Okay, now so now for a time being, just I will delete this also to have a maximum area. So we'll connect it here. That's fine. Okay, so we got a true length here. So this is a b1 dash and a and a b. Okay, now we need an apparent length. So apparent length and apparent inclination. So how to get a apparent length and apparent inclination is, so now we got this as a true length. So when we see the same line from the top, okay, so somewhere here, so this as if looks like there are two straight lines exactly from here to here, then from here to here. Okay, from the true length from both the ends, there will be exactly a straight line dropping from the B dash, okay, till the locus of A here. Okay, so you can just drop till the locus of A. You can just see here. Okay, then so this will be our top view length from here to here. Okay, that is 69.28. So now I need to locate, this is end B. Okay, so this end B now lies on the locus of B1. So what we need to do here is, so below the line option, the third one, okay, there is an option called arc by center point. Click on that one. So center will be A and the end will be B here. Okay, so now take a arc and cut it across the locus of B. Okay, you can just check it out here, like here it intersects with the locus of B. Now I will go to a line. Now I will change the line thickness to 0.5. So from end A, okay, till the intersection of this one, I will drop one line. So this point is a B. This point is a B, and this is nothing but a top view. Okay, so it is not connected properly. Let me just check. Okay, so this will be the B and the top view. Let me just check the length here. Go to the smart dimension, click on this one, just drag it down. It is 69.28 and measure the angle here. Angle between, so this line and this line will be 55 degree. Okay, that means the length in the top view is this much, and the apparent inclination with respect to the VP is a 55. That is nothing but a beta. Okay, so now we'll repeat the same thing in order to get the front view. So what we'll do now here, okay, we'll take a line first. Okay, so from the true length here below the XY line, from the true length below the XY line. Okay, so straight line till A dash, straight line till A dash. Sorry, the thickness is changed now. We'll keep it 1 3. Okay, now arc by center point. So this is our front view. From the end, we'll just draw one line here. Okay, so keep the line thickness 0.13. It is changing now. Okay, okay, so there is a problem with the mouse. Okay, let's say like 0.13. Now take a line, okay, from the end A. Okay, just zoom this properly where we will get an intersection. Move on this line, and wherever you get intersection, just click there. Okay, or else you can go to the trim option. Okay, before dropping the line itself, you can just trim this and this. You will get a endpoint here. Now fit to the screen, just zoom the front view. So now this will be the front view. So I will go to the name and will say this is my B dash, B dash, and I will go to smart dimension, click on this one. So that will be 56.57. Let me go back to the angle between this and this will be 45 degrees. So this is my alpha. So let me just move this B dash a little bit up here. Okay, so this is how exactly we're going to do. So now go back to this data sheet here. Okay, so we here start theta we have given as 30, pi they have given it as a 45. Now apparent inclination alpha we got it as a 45, enter. Beta we got it as a 55, enter. Okay, so what is the apparent lengths we have? Here we have a top view 69.28 mm, then front view 56.57 mm. Okay, so whatever the data he has asked, we got it. Okay, so this is how exactly we can solve a problem with respect to the lines when they give the true length and true inclinations here. Okay, so that means, see, we got a true length, easy to locate the things, and very important thing is whenever we are solving a problem on a lines to locate these four locus lines. Okay, once you understand how to locate those, or once you get those four lines, okay, four locus lines with the given data, then the remaining things will be easy. Okay, so if you have a true length to get a top view, okay, so first straight line till the locus of one end here, then the arc. Okay, and if I have to cross check whether I have done the problem in a right way or not, at once you finish problem, you can go back to the line, take a 0.13 line, From the end of the front view, just draw one line to the end of the top view. So both are coming in the same line. Okay, so that itself shows like whatever the problem you have done is a proper. So the distance between this whatever the vertical line and the end of A, okay, is called as a distance between end projectors. We have a type 2 problem where we are going to come across these distance between end projector. Okay, that means end projector means, so there are two ends, that is A and B, which will be lying at a distance of 40 millimeter. So when we have such a problem, okay, so this is how exactly we can solve. So if you have any doubts and all, you can just clarify it. Okay, so or else you can just listen to the things once again. Okay, so you will come to know. Okay, so try to have the an habit of like dropping the name, okay, dropping the dimensions whenever you finish the problem. So that make sure that like you are not going to miss out anything. And maybe once you're going to do the dimension at the end, if something goes wrong, again you need to repeat from the beginning. Okay, so thank you.